guys, welcome to this lesson. We're going to continue our studies with object-oriented programming, and we're going to dive in and explore some different ideas with character development with OO programming.
I figured because it's Halloween, I could play around with some new little technologies here. Curious how that's going to work, but we'll see. So what I'd like to do today is kind of walk through some ideas around object-oriented programming. We've begun to introduce you guys to this idea of objects and classes and being able to instantiate objects from classes and all these new ideas that we can employ in our programs. So what I'd like to do in this assignment is I'd like to think about a top-down kind of style platformer game. And specifically, I want to think about a character and how we can design a character in our code. So I know a lot of us like to play video games, myself included, and I want to think about this from a character perspective. And just to kind of frame this a little bit, I'm going to come over to this site. This is Pico 8, which I recommend everyone checks out. It's actually a fantasy console. So it's think of it like an NES, like an 8-bit console system, but one that has never actually existed in real life. It's just developed in a piece of software. It's an emulator, but it's also a development environment. And communities of people come together around the world and they develop video games with it. And it's a fun little platform to kind of just learn programming, learn game design. And because it's Halloween, I figured let's kind of change it up a little bit. And this game right here, this Don't Dig Up the Dead, I think is a good example of the type of character movement that I'd like to implement right now in this assignment. So I'm going to go ahead and hit play right here. And this is going to load up the game. And this is super simple. We're thinking top-down movement, just like the old just the Legend of Zelda games. So let's go ahead and start this. Let's see. Why am I not? Oh. There we go. It booted into the wrong game, I think. So these are all indie games. They're all developed by small groups of people. Now this is a top-down game. You've got this little character right here that's moving around and you can interact with different things. Graphics are very simple, and the character is very simple. And what we're going to develop is actually going to be somewhat more simple than this. But what I'd like to illustrate here is this idea of moving around a character on the screen like this. So we're just kind of moving around the screen. In this case, we're kind of staying in the center of the screen and the map is kind of moving around us. Now, we may not do it exactly like that, but the point is that we're able to draw a character and move a character. So if I come out of this, I'm going to go ahead and pause this. And we come into our P5JS environment. We want to think about the basics, right? The fundamentals of what we're trying to accomplish here. Basically, just a character that can move around the screen. So we can draw a shape on the screen and we can control that shape with our input. We know how to do that, right? We went through that. We know how to listen for keyboard input and be able to move around an object on the screen. But we want to abstract that a little bit more inside of a character that we can build on. So when we think about building some type of object, we're always thinking about trying to build a blueprint for what we're trying to describe. Just like we did in class, we're thinking about this idea of a house and developing a blueprint for that house so that we can go out there and we can build an unlimited amounts of houses. Now, in this example we're going to do in this assignment, we're only going to develop one character. Next week, we're going to expand on this and see how we can use what's called arrays to manage a whole collection of instantiated objects from a single blueprint or class. This is what enables a lot of the really interesting capabilities of building dynamic interactive systems, when we can think about these blueprints and then using these blueprints to stamp out new objects. So when we think like this, we initially think of, all right, we need to develop a blueprint. And the way we would do that is simply type class to define that blueprint, and then we call the class whatever we'd like. In this case, I'm calling it character. Now, our character is always going to need a constructor, right? So the constructor is a special function that we're going to use to construct the actual object from this specific blueprint or class. You can think of this function as a function that gets automatically called whenever we create a new character. Okay, so a constructor is really where we initialize all of the instances properties. Okay, now in this case, we're going to probably want our character to live in some type of section in our program or on our display, right? So this is typical of graphics programming. We need some type of X and Y coordinate. So I'm going to go ahead and input inside of this constructor an X and a Y coordinate. That's going to allow us to specify the starting position of our character. Without this, we would hard code it inside the constructor. We want to make it a little bit more flexible by saying X and Y as an input to the constructor. So now once we have that, we could say this.x is equal to the inputted X, and this.y is equal to the inputted Y. Now what we did was we initialized two properties based on two input properties to this character. Again, we're just creating a blueprint for a character, nothing more, right? And in this case, all of our character, all that the character is at this point is literally 2 points in space, an X coordinate and a Y coordinate, and that's it. But let's continue to build on this. So maybe we want a character to also have, say, I don't know, a size. And we can maybe fix size that, say, to 10 for now. And maybe we want to have a color. And we'll make the color, say, red for now. Now, these are two hard-coded properties, right? These are hard-coded properties. So these would be the same for every instance of a given character. That is different from these dynamic properties, which are different based on the input values we give to the constructor. Now, we'll explore that once we start to actually construct our character. But for now, we're keeping it really simple. Our character is just going to be a basic shape on the screen. I'm going to encourage you to maybe try to drop an image in there, but let's just keep it simple for now, and let's get a character moving on the screen, kind of like a wireframe. So let's go ahead and make sure I'm still recording here. Okay, good. Excellent. So now our character has some basic properties, but now it needs some type of behavior. What do we want our character to be able to do? Now, fundamentally, when we're talking about graphics programming, typically there are two core things that I would argue are usually taking place when we're developing our blueprints for objects that are going to be on the screen. That is, we want to be able to move, right, or update the actual position of our character, and we need to be able to actually draw our character. So we're going to go ahead and define some methods, what we can call behaviors of our character. Now the first thing is, let's go ahead and do a draw method. Now, like we saw in class, we don't include the function keyword here. We just say draw, right? That's it. We don't have to declare function. And now when we draw our character, we're going to want to use some of the properties that we've defined in our constructor. So let's go ahead and use that. Let's make our fill the color that we set initially, this.color. And let's go ahead and make our character an ellipse for now. We're going to just make it an ellipse, and the ellipse function, as we know, the first parameter is the X position and then the Y position and then the size. So we have a hard-coded size. So we'll use all of these properties. So now notice how in our draw method, we now are drawing to the screen, And we're using all of these properties that we've defined inside of our constructor. Awesome. Now we could try to go ahead and actually I'm auto refreshing here, so we could try to go ahead and run this, and we shouldn't get any errors. We should have no syntax errors because the code is valid, but it's not going to actually display anything just yet because we're not doing anything, right? Before we actually try to create a character, let's continue to develop our behaviors. Now I want to go ahead and also be able to move this bad boy, right? We want to be able to update them. So I'm going to actually say move instead of update because it's more contextual to what this character is actually going to do. Now, we could define some type of direction here, right? Where we input the direction to the move. So we could say, hey, whenever we move our character, give it a direction to move in. Right? So we're inputting to this behavior, the move behavior, the capability to move in a specific direction. Now this direction, as we'll see in a little bit, could be up, down, left, or right, right? So if we know that we're getting an input of up, down, left, or right, and we want this move function to enable the character to move in any direction, we need to make a decision based on that value, right? Based on the value of the direction variable. So what tool in our toolbox that we've been learning lets us make a decision based on a value? Hopefully you said it. It's a conditional statement, right? So we can write conditional statements that test the value of that direction and allow us to move the character in a specific direction based on the value of that direction. Awesome. So how do we do that? So in order to do that, what we could do is inside of this move function, now watch your curlies, right? There's a lot of curlies going on here. We're going to say, hey, if the direction is equal to, say, up, we're going to go ahead and we're going to change what property if we're moving up. It's going to be the y position, right? So we're going to say this dot y, and we could say minus equals, let's increment our movement by 5 here, and let's see if that works out for us. Okay, awesome. So we have a direction to move up, and we're going to go ahead and subtract y by 5, which will move it up the screen. Now, all we have to do now is do this for every single direction, and we'll be able to go ahead and move in all directions. So I'm going to go ahead and copy this and paste this, and we're going to do the opposite here and say if the direction is equal to down, then go ahead and plus 5 to y, and then I'm going to paste this here 2 more times, and we're going to say if it's left and right, and now instead of the y position, we're going to make the x position. And if we're moving left, which is going to be this way, we're going to subtract x. And if we're moving right, we're going to add x. So all this move function is doing, this move method is doing, is testing the direction that we give it. And based on the value, we're manipulating, changing the property of x and y of our character. That's all we're doing. Super simple. Right? We're using all the tools in our tool belt. Notice how there's a lot of curly brackets here, right? So keep in mind of how many curly brackets you are. Everything that we're doing here is inside of this character class. If I collapse that, everything we just wrote is inside this character. We're describing the character. We're developing this idea of a character, right? And remember, we're not taking anything for granted. The character started its life with just a simple constructor that just knew its position in life. Now what it has is it has a draw method that knows how to draw itself using an ellipse, and then it also knows how to test for movement and change its position based on a direction. So we have a basic blueprint in place. We have this basic blueprint for an actual character. I think it's time now that we can actually try to use this, right? How do we actually use this character class to see if we can actually get it to work? So let's go ahead and let's create a new player. So we're going to call this a player, right? We'll call the player an instance of a character. So right outside of this character class. So here I'm outside now. I'm not in the character. We're going to go ahead and I'm going to actually use the let notation, which is really a newer way to say it in JavaScript. So I'm going to start to use this let to show you a little flexibility on how we can define variables. And I'm going to say player is, I'm just going to say let player here. So we're defining this global player variable. And then now inside of the setup function, we're going to instantiate or create our player. Now, hopefully because I'm using these two different pieces of terminology, a player and a character, I'm trying to draw that distinction between the instance of a character, which is just our player, and the actual character blueprint that we just developed using our class. So I'm going to say player inside of our setup function is equal to new character. And let's go ahead and place the character in the middle of the screen. So I'm going to put it at 200, 200. So we're giving it the initial position of where the character should actually be, but it's not actually doing anything yet, right? We just created this new character and we placed it inside of this player variable. So the player variable contains all of the data that we just defined inside of this blueprint. It has the X and Y coordinates, it has the size, it has the color. It has these two behaviors, these two methods, move and draw. Awesome. So now we have an instance of this tool or this character that we can use. Very cool. So now, what can we do? Now we can actually start to call some of these methods. Now, where are we going to want to do this? Let's go ahead into our draw function here, because this is going to be inside of our draw. We want this to loop. We're going to say player.draw. And look at that. Our player just spawned into existence. We just spawned a player. Think about this. A lot like the game we were just looking at, where the player spawned in the middle of the screen, is exactly what just happened here. Now, I understand that may be a conceptual kind of visual leap, but I'm trying to kind of build those dots for you to see how this fits together. How do we go from this basic example to an actual, what would look like an actual game? So we have this dot here, which is representing our character, but we can't actually move it yet, right? So let's go ahead and try to move this bad boy. Now we remember how to actually listen for key pressed events, right? What function do we need to use, right? We need to use a different function. The key pressed function, right? So if we define our key press function, now we're listening for keyboard input. Now what we could do is we can do the same type of conditional statements that we did inside of the move, but we're going to go ahead and do it with the actual key code global variable, which allows us to read what the user actually hit. So what we're going to do is we're going to say here, we're going to basically do the same thing. We're going to say, hey, if key code, I think that's camel case here, is equal to, and there's some constant values here that we can use, up underscore arrow, and if the key code up arrow is detected, then what we're going to do is we're going to say player dot move, and now we could just give it up. Now let's see what happens. If I go to our game here and I press the up arrow, boom, our character's moving. Nice. Now it's not going to move down, it's not going to move left, it's not going to move right, right? It's just going to move up. So all we have to do is include the rest of these conditional statements. So I'm going to go ahead and we can actually do else ifs here if we wanted to, but I'm just going to do a collection of ifs. So I'm going to go ahead and copy this 4 times, and we're going to say if it's the down arrow, then move down. If it's the left arrow, then move left. And if it's the right arrow, move right. I gotta keep making sure that I'm recording here because I've done this too many times where I record this whole thing and then it's not recording and I'm like, ah. Okay, so now we have all of our key press conditionals in place. Now if we go over to our program and we I'm hitting the WASD keys. Up, down, left, and Wait, my right's not right. Oh, I got a typo here. It's got to go right. Oh, now we can move our character around. There we go. So we have basic character movement. And that was pretty quick. I don't know how long I've been recording for, but I didn't want to make this video crazy long. I think that's where I'm going to stop this. I encourage you to try to think about how you would extend this character to maybe not use the ellipse and maybe use an image that you have yourself. So think about that for a second. How would we change this and put an actual image in here? I'll give you a hint. It's just like the DVD logo project we did. So you can drop a character in there, maybe something that you've drawn, that you scan in, or you've drawn on the computer. But think about it. And maybe even think about ways we can make this movement a little bit smoother, right? Like the movement of 5 pixels isn't the best. It doesn't feel that great. I can't hold down a key and move, which isn't great. I have to like kind of tap the key. So think about ways that you can extend this, but the core of this lesson is really to continue to work out this idea of object-oriented programming where we're thinking about a character. And in this case, our character at its basic level needs to be able to position itself on the screen in an X and Y coordinate. It needs to have some basic attributes about what it looks like its size and its color. Maybe it's an image. It needs to actually be able to take that visual data and draw it to the screen. So that's the first behavior that it has. It's the first method, is to be able to draw. And then it also needs to be able to move. We want to be able to move around the screen. So think about maybe some other behaviors that a character in a world you were creating may need to have, right? There may be shoot, or maybe run, or something like that, or maybe more creative ideas outside of that. So think about this, and yeah.
And happy Halloween. Hope you guys all have a good day today. I'll see you Monday. Bye.